In this video, I am going to discuss about distortion in welding process, residual stress in a welding process, and weldability of ferrous and non-ferrous material. So, distortion in a welding process. In a welding, the temperature at a different area of the joint are different. Welding process consists different regions: fusion zone, heat effect zone, cooler metal zone. All these zones, the temperatures are different. So difference in temperature causes different expansion in this area. After welding, different area of the joint contract differentially due to this different temperature. So different area of a welded joint have different expansion and contraction. But the welded workpiece acts as a solid body and it can't contract and expand differentially at different areas. This uneven expansion and contraction of the welded joint due to uneven heating and cooling create a stress in the welded joint. So what is the reason behind creating a stress in the welded joint is uneven heating and cooling at different areas at different rates. So this will create a stress in the welded joint. This stress make the welded job to change in size and shape permanently, and this is called distortion of the welded joint. Actually, that is a defect, distortion of the welded joint, or a failure. So what's the reason behind distortion of a welded joint is uneven heating and cooling of a welded joint. And the welded joint that can't expand and contract locally, so it will create a stress. That stress permanently change the shape and size of the welded joint. That is known as distortion of the welded joint. See, this is a welded joint. Here is a fusion zone, and this is HAZ, and this is the cooler zone. So these all regions have different temperature. Due to this different temperature, the welded joint expanding differentially and cooling differentially. But this entire welded joint is a solid body, so it can't expand and contract different rate at different region. So it will create a stress. That stress permanently change the shape and size of a welded joint. That is known as distortion of the welded joint. There are three types of distortion. Longitudinal distortion occur along weld line. Suppose this is a weld line. This longitudinal distortion will be occur along this weld line. Transverse distortion occur perpendicular to weld line. Angular distortion usually occur in fillet joint. Fillet joint means 90-degree joint. The transfer angular distortion will be occurring. So this is the fillet joint. Okay. So these are the three type of distortion: longitudinal distortion, transverse distortion, angular distortion. So prevention of distortion. How we can prevent distortion? Reducing the effective shrinkage force. Making the shrinkage force to reduce distortion. Balancing shrinkage force within another shrinkage force. So these three are the method which is used to reduce distortion during welding process. Reducing the effective shrinkage force, making the shrinkage force to reduce distortion, balancing the shrinkage force with another shrinkage force. So next one is weldability of ferrous and non-ferrous metal. What is the condition of weldability of ferrous metal and non-ferrous metal? See, ferrous metal like steel and cast iron are easier to weld. The ferrite martensitic type stainless steel are not weldable quality of their crystalline structure. So ferrite martensite stainless steel are not weldable. Austenite type stainless steel is a good weldable quality. Austenite stainless steel ആണ് commonly weld ചെയ്യാൻ പറ്റുന്നത്. The austenite type stainless steel is called 80/8 stainless steel, which contain 80% chromium and 8% nickel. To eliminate corrosion in this type of stainless steel, Stabilizing elements such as columbium, titanium, molybdenum, synchronium added to small percentage called stabilized type stainless steel. So സ്റ്റീലിൻ്റെ കേസിൽ ഓസ്നൈറ്റ് സ്റ്റെയിൻലെസ് സ്റ്റീലാണ് വെൽഡ് ചെയ്യാൻ പറ്റുക. അതിൽ 80/80 സ്റ്റെയിൻലെസ് സ്റ്റീലാണ് വെൽഡ് ചെയ്യാൻ പറ്റുക. കൊറോഷൻ പ്രിവെൻറ്റ് ചെയ്യാൻ വേണ്ടി കൊളംബിയം, ടൈറ്റാനിയം, മോളിബ്ഡം, സിങ്കോണിയം പോലുള്ള സ്റ്റെബിലൈസിങ് എലിമെൻറ്റ്സ് ചേർക്കും. സോ അതിനെ സ്റ്റെബിലൈസ്ഡ് സ്റ്റെയിൻലെസ് സ്റ്റീൽ എന്നാണ് പറയുക. See, in the case of cast iron, grey cast iron is weldable type. It contains 3 to 4% carbon. A 5 mm size round rod or square high super silicon cast iron filler rods containing 2.8 to 3.5% silicon are used for cast iron welding. So cast iron welding use ചെയ്യുന്ന filler rod എന്ന് പറയുന്നത് super silicon cast iron filler rods ആണ്, containing 2.8 to 3.5% silicon. The preheating temperature of the cast iron is 200 degrees Celsius to 310 degrees Celsius. ഇത് വളരെ ഇമ്പോർട്ടൻ്റ് ആണ്. What is the preheat temperature of the cast iron? 200 degrees Celsius to 300 degrees Celsius ആണ്. Okay. Then that's about ferrous metals, steel and cast iron. So non-ferrous metals like aluminum, copper, titanium are more challenging to weld, more difficult to weld. These metals tend to conduct heat quickly, which can cause issues like warping, burn through. Additionally, they often form oxides on their surface, which must be removed before welding to ensure a clean, strong joint. So ferrous metals അതേപോലെ തന്നെ നോൺ ഫെറസ് മെറ്റൽസും വെൽഡ് ചെയ്യാനുള്ള കണ്ടീഷൻസും കാര്യങ്ങളൊക്കെയാണ് പറഞ്ഞത്. അത് സ്റ്റീലും അതേപോലെ തന്നെ കാസ്റ്റ് അയണും. ദെൻ നോൺ ഫെറസ് മെറ്റൽസിൽ അലൂമിനിയം, കോപ്പർ ആൻഡ് ടൈറ്റാനിയം. ഓക്കെ. ദെൻ റെസിഡ്യൂവൽ സ്ട്രെസ് ഇൻ വെൽഡിംഗ്. What is the concept of residual stress? See, residual stress are stress present in the engineering component even when there is no external load, and these develop due to heat treatment, machining, mechanical deformation, casting, welding. എന്താണ് റെസിഡ്യൂവൽ സ്ട്രെസ്? റെസിഡ്യൂവൽ സ്ട്രെസ് എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ഒരു എഞ്ചിനീയറിംഗ് കോമ്പണൻറ്റിൻ്റെ ഇൻറ്റേർണലി ഉള്ള സ്ട്രെസ്സിനെയാണ് residual stress എന്ന് പറയുന്നത്. There is no external load will be acting over the engineering component, even though there is a stress will be there in that component or a workpiece or anything. That stress is known as residual stress. They develop due to heat treatment, machining, mechanical deformation, casting, welding. ഈ പ്രോസസ്സുകളൊക്കെ കഴിഞ്ഞാൽ there will be a residual stress. See, residual stress in welding are internal stress that remain within a material after welding. That's the point. Residual stress in welding are internal stress that remain within a material after welding. These stress arise due to the non-uniform heating and cooling of the material. വെൽഡിങ്ങിൻ്റെ കേസിൽ റെസിഡ്യൂവൽ സ്ട്രെസ് ഉണ്ടാകാനുള്ള കാരണം എന്ന് പറയുന്നത് നോൺ യൂണിഫോം ഹീറ്റിംഗ് കൂളിംഗ് ഓഫ് ദ മെറ്റീരിയൽ ആണ്. സോ ഡ്യൂറിങ് വെൽഡിംഗ് causing localized expansion and contraction that create residual stress. So causes of residual stress. First one, non-uniform heating and cooling. So non-uniform heating and cooling during welding process that creates residual stress. Second one, contraction mismatch. See, difference in thermal properties of the material, such as coefficient of thermal expansion between the welded material and its surrounding result in the contraction mismatch. So contraction mismatch means difference in the thermal properties of the material that has been undergoing welding process. Then metallurgical transformation. See, during the welding process, the microstructure will be changing. Grain structure will be changing. That microstructural change also causes residual stress. Then restrained movements. The surrounding material and previously welded section act as a constraints, limiting the free movement of the welded material during cooling. So restrained movements means if there is any other welded joints near, that will prevent the movement of that part. So during welding, it will not have the capability to move during solidification or cooling stage. That will create residual stress. So these are the reason for creating residual stresses. Once more, non-uniform heating and cooling, contraction mismatch, metallurgical transformation, restrained movements. Next one, prevention of residual stress. First point, Controlling welding parameters. Adjusting the welding parameters such as heat input and welding speed helps in minimizing temperature differentials, thus reducing the development of residual stress. Welding parameters adjust ചെയ്യുക, heat input, welding speed adjust ചെയ്ത് കഴിഞ്ഞാൽ residual stress development കുറച്ചെടുക്കാം. Second one, preheating. Preheating the material before welding help achieve more uniform heating and cooling, creating the effect of reducing the effect of residual stress. So preheating ചെയ്ത് കഴിഞ്ഞാൽ മെറ്റീരിയൽസ് വെൽഡ് ചെയ്യുന്നതിന് മുമ്പ് തന്നെ പ്രീഹീറ്റ് ചെയ്ത് കഴിഞ്ഞാൽ റെസിഡ്യുവൽ സ്ട്രെസ് കുറവാണ്. സെക്കൻഡ്, നെക്സ്റ്റ് വൺ, പോസ്റ്റ് വെൽഡ് ട്രീറ്റ്മെൻറ്റ്. സ്ട്രെസ് റിലീവിംഗ് ഐലിംഗ് ഇൻവോൾവ് ഹീറ്റിംഗ് ദ വെൽഡഡ് കോമ്പണന്റ് ടു എ സ്പെസിഫിക് ടെമ്പറേച്ചർ and then gradually cooling it, eliminating residual stress and improving material properties. Post weld treatments, അതായത് വെൽഡിങ് ചെയ്ത കോമ്പണൻറ്റിനെ ഐലിംഗ് ചെയ്യുക. ഐലിംഗ് ചെയ്യുന്ന സമയത്ത് സ്ട്രെസ് എന്താവും, റിലീവ് ആവും. then it will improve the material properties also. Then peening. So peening, mechanical method like peening, hammering or short blasting the weld surface, introduce compressive stress, countering the tensile residual stress induced welding. See, peening means welding ചെയ്ത ജോബിനെ ഹാമറിങ് ചെയ്യുക അല്ലെങ്കിൽ ഷോർട്ട് ബ്ലാസ്റ്റ് ചെയ്യുക. അപ്പോൾ റെസിഡ്യുവൽ സ്ട്രെസ്സിന് ഓപ്പോസിറ്റ് ആയിട്ട് കംപ്രസീവ് സ്ട്രെസ് പ്രൊഡ്യൂസ് ചെയ്യുന്ന സമയത്ത് റെസിഡ്യുവൽ സ്ട്രെസ് എന്ത് ചെയ്യും, അത് റിമൂവ് ചെയ്ത് പോകും. ഓക്കെ, സോ ദീസ് ആർ ദ മെത്തേഡ്സ് ഫോർ റെഡ്യൂസിങ് റെസിഡ്യുവൽ സ്ട്രെസ്. So controlling welding parameter, preheating, post heating, then peening. Okay, so in this video I have discussed about distortion welding, then weldability of ferrous and non-ferrous metal, then residual stresses. Thank you.